I'm Don Ingber. I'm the director for the Wyss Institute for Biologically Inspired Engineering at Harvard, and I'm here because I was asked to describe this new device we've developed, which we call a human breathing lung on a chip. It's a little flexible device that's fabricated using microengineering techniques developed initially to make microchips for the computer industry, and we make small channels in here that are lined by human cells, airway cells and blood vessel cells, and it actually breathes, and we use this to test for drugs and environmental toxins, hopefully someday to replace animal studies. When we set out to develop the device, we really looked to nature for inspiration. The lung is made up of many small air sacs. This is really where all the functions occur: gas exchange, infections, toxin absorption. And the air sac is really a rather simple structure in that it's lined by one layer of lung cells, and then there's a matrix that's flexible and porous, and then there's one layer of capillary blood vessel cells. And so we recreated this using microengineering techniques by making small channels in this flexible material that are lined by airway cells, capillary blood vessel cells, and they share a common membrane that's flexible and porous. And we're able to apply suction into neighboring channels that makes us stretch and release, and it literally mimics what the lung cells experience when we breathe. It's this ability to combine all of these different features in this little flexible device that we see in the whole lung that allows us to predict results that we actually show we can confirm in animal studies. We're already using human cells in these devices. Hopefully someday we could use a patient's own cells to even develop personalized therapies. We also think that we could integrate different types of organs together. So for example, a heart and a lung, or a bone marrow and a cancer. The idea is to link these together. You could see immune response, you could see multi-organ functionality, and I think that's really going to be a whole new path for drug development in the future.